since some of you are requesting that I should do a video about this one, so here it is. Okay, so it is actually a very easy theorem. You just need to know the definition. So over here we are having this theorem. It states that product of two stochastic matrix is again stochastic. Okay, so the proof, it goes like this. So let A and B be stochastic matrices. So what can you say if they are stochastic matrices? It just means that every row, it is a probability vector. That we can say that since it is a probability vector, each row, so all the entries, they should be non-negative. So we can say that Aij, it's greater than or equal to 0. All the entries of A, they are greater than 0. And all the entries of B, they are also greater or equal to 0 for all I, j. Okay, so what is happening over here? Okay, you can actually think in this way: A1n, an1, an2, ann, and then you are having this matrix B, b11, b12, b1n, bn1, bn2, bn. Okay, similarly, okay, it will have some elements in between as well. Okay, so what is happening? So all these entries of A and B, they are non-negative. Okay, and also each row, if you add this row, it will be equal to 1. If you add this row, it will be equal to 1. If you add any row, it will be equal to 1 because the rows will be probability vectors. Similarly, if you add these rows, will be equal to 1 also. If you fix a row I for any row I, okay, so the entry of this row, summation A, okay, so over here, since we are fixing the row equal I, AI1, AI2, AI3 to AIN. So if you add all these entries, it will be equal to 1. So Aij, okay, the row is fixed, it's I, Aij, j equal 1 to n, it will be equal to 1. And also, similarly for B, if we are fixing this row as I, then summation j equal to 1 to n, Bij will be equal to 1. Okay, so even if you take I to be equal to 1, this will work. If you put I equal 2, it will work. If you put I equal k, it will work. Okay, so for any row, it works for any row. Okay, so now we just need to see. Okay, so now we just need to find the product of this matrix and then see that each row is equal to 1. Okay, so if you multiply this matrix, it will be very complicated. Okay, because you will have to multiply this row with this column to get this entry, multiply this row with this column, you will get this entry. Okay, but now what we shall do is this. Okay, since we are interested in proving that this product AB multiplying this matrix with this, we need to show that it is a stochastic matrix. So we will be taking any row I of this matrix. Okay, after multiplying, we are taking a row I. Okay, we find the sum of this row, we will show that it's equal to 1. Okay, but we don't do to complicate things by multiplying this matrix and then finding this sum. Of course we can do that. Okay, but it will take too much time, and also we will have to write a lot of things which we don't want to do. Okay, so actually what we can do, firstly, you should know that if you multiply this matrix and this matrix, all the entries will be non-negative. Okay, so what can we do? Since over here we are multiplying matrix A and B, and both of them, they are of order n by n. So similarly over here we can get a matrix n by n. Okay, we can just denote this one as C11, C12, C1n. Okay, C11, it can be obtained by multiplying the first row with the first column. C12, again we can take the first row with the second column. Okay, multiply them as multiply matrices. Okay, so we can actually denote it like this. Okay, we can do it like this. Okay, so let AB equals C. Let AB equal to C. Therefore, Cij will be greater than or equal to 0, since, okay, the reason is since this one and this one is greater or equal to 0 for ij. Okay, now what will we do? We will fix I. We will fix a row I. Now, for row I of the matrix C, which is the product of AB, sum of the entries, it's equal to. So we are fixing the row I. So over here again we will be having Ci1, Ci2, Cin. Sum of the entries will be summation j equal 1 to n Cij. Okay, but now what is Cij? Cij, it can be C11, C12, it can be any of these. Okay, so Cij, it can be any of these entries. We are adding them all. C11, Ci1, Ci2, we are adding them all. Okay, so now we just need to know how does Cij looks like in terms of A and in terms of B. Just like I said, because Cij, it is the ijth entry of C, so this can be obtained. Okay, I will just write it down. Cij is obtained by, it's obtained by multiplying the ith, since C equal AB. Okay, keep that in mind. It's obtained by multiplying the ith row of A and jth column of B. So the ith row of A, it is AI1, AI2, AIN. You multiply with the jth column. The jth column, it is A1j, B, B2j, B and J. So if you multiply this one, you are noticing that it will be a matrix. The order of this one, it is 1 row, n columns. The order of this one, it is n rows, 1 column. So Cij will be an entry, so it will be a 1 by 1, 1 by 1 matrix. So how do we do it? It will be AI1 multiply with this B1j plus AI2 B2j. We keep on doing this one up to AIN B and J. So since it is a 1 by 1 matrix, okay, we can easily remove this square bracket for the matrix symbol. Okay, since we are having 1 by 1. This one actually we can write it in terms of summation. I, it remains the same. AI, everywhere it begins with AI. Okay, similarly, the second entry it changed. Okay, similarly, B, the last entry of B, J, 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 J. So what changes? It is actually this one in between, 1, 2, up to n. So we can write this one as K, this one as K equal 1 to n. Okay, so this one can be expressed in terms of summation like this. So over here we can write, okay, you don't need to write this one, okay, it is just an explanation in case you had forgotten. So this one we can write it, Cij we can write it as summation Aik Pk j, j equal 1 to n. what will we do now? Again, we can expand this summation, okay, just like we did. Okay, since why am I writing in summation even though we need to expand it? Because it's actually we don't need to write the thing that was written over here. That's why we are simply writing this one as a summation. Actually, this one you can always remember that when you are multiplying two matrices AB or PQ, then if you denote this one by C, then whenever you have Cij, it will be Aik Bkj. Sorry, PQ, so it will be Pik Qkj, where k equal 1 to n. Okay, so it works. Okay, so even if you denote it with any other letter, it will still work, so no problem. Okay, now let us expand. Okay, if we expand this one, so this one is actually k equal 1 to n, so it will be ai1 b1j plus ai2 b2j plus so on ain bnj. Okay, summation of this. Okay, we can take the summation again separately. J equal 1 to n, ai1 b1j plus summation ai2 b2j plus summation j equal 1 to n ain bnj. So this is what we are having. Now what is happening over here? This summation, the index, it's j. Okay, so this one, it doesn't depend on j, so you can take it outside of the summation. So you will be having ai1 summation b1 b1j j equal 1 to n plus similarly this one you can take it outside the summation, which will be ai2 summation b2j j equal 1 to n. We keep on doing this one until we reach the last term ain, take it outside, j equal 1 to n bnj. Okay, this b1j you cannot take it outside of the summation because over here the index is j. Okay, so this term depends on j as well. That's why we cannot take it outside. But the term before we can take it outside because it doesn't depend on the index. Similarly everywhere. Okay, so now let us take a look at this quantity b1j j equal 1 to n. What is happening over here is b11 b12 b1n bn1 bn2 bnn b21 b22 b2n. This summation, if you notice, it is this. It will be b11 j equal 1, j equal 2 will be b12, j equal 3 will be b13, up to j equal n will be b1n. So this summation will be this summation of the first row of the matrix B. So it will be 1 because it is a probability vector. Similarly over here it will be 1 because this one is the sum of the second row. Similarly you keep on doing it, it will be sum of the third row, sum of the fifth row, and so on up to sum of the nth row. All of them will be equal to 1. ain so you will be having ai1 plus ai2 plus ain. Now this one, it is the sum of the ith row of A, so it will be equal to 1. So this is all for today. Until next time.